Welcome to another physics class. Today, we are going to another topic entirely, and the topic is inertia and inertial mass. And when you say inertia in physics, it's closely related to motion. And we have various definitions of inertia. The first one is that inertia is the tendencies of an object to continue in a state of rest, or if it is on motion, to continue in a uniform motion on a straight line, unless acted upon by an external force. That is, if an object is at rest, it will remain at rest. Or if the object is on motion, it will continue in its motion, uniform motion, in a straight line, unless it's being acted upon by an external force. So let's write inertia is closely related to motion in physics. Then definition now. Definition of inertia. The first one is the tendencies of an object to continue in state of rest or uniform or constant motion in a straight line, unless is acted upon by an external force. This is the first definition of inertia. Two definitions. Two is the resistance of an object to a change in motion. That is, the resistance of an object to a change in motion is what meant by inertia. Next is type of inertia. We have one, inertia of rest. Two, we have inertia of motion. And number three, we have inertia of direction. Now let's take it one after the other. Take it one after the other. Inertia of rest. It means the resistance of an object to move when it has rest. But when an object is at rest, it's resistant to move when at that state of rest. Is what meant by inertia of rest. Inertia of motion is the tendencies of an object to move at the same speed or uniform speed. Inertia of direction, that's number three. That is the tendencies of an object to move in a straight line unless an external force is acting on it. That is, when an object is moving on a straight line, then the tendency to move on that straight line if an external force is acted on it. Now let's take examples of inertia according to the tides. Examples of inertia according to the tides. The first one will be based on inertia of rest. 1. A coin placed on a paper resting on a glass cup. A coin placed on a paper resting on a glass cup. Now, according to what's shown on the screen, if you look at that coin, the coin is placed on a paper, and both the coin and the paper on a glass cup containing water. Since the coin is at rest, by the time the paper is tried to remove or uncover the cup, what you are going to notice is that due to the force or the weight of the coin will drop inside the water while the paper will be removed away. That is due to the fact that the coin is at rest, and that is inertia of rest. If the coin is not at rest, then it's supposed to move with that paper. 2. A car at rest suddenly move the upper part of the body of passenger move backward due to inertia at rest. Now, as shown on the screen, when the car is at rest, the passenger will sit down comfortably. But when the car suddenly moves, the upper part of the passenger will fall backward due to the inertia at rest. A car on motion suddenly apply brake or hit accident the upper part of body of passenger move forward due to inertia of motion. To prevent this, That is to prevent the inertia of motion when a car is suddenly applied brake. Seat belt must be applied so that the passenger / the driver will not move off the seat. Now, as we are looking at it from the screen, when the passenger is without seat belt and the car is on motion, suddenly applied brake, you can see that the passenger, the upper part, move forward. But when the seat belt is applied, then both the passenger and the driver will not move off the seat. It will keep them at rest, just to prevent the inertia of motion. That's the essence of using seat belt in a vehicle. 4. A basket of fruits. Place on a smooth slant road. Suddenly hit an obstacle. The upper fruit from the basket move off due to inertia of motion. According to the diagram shown on the screen, if you look at the basket containing fruit moving down that slant road or hitting the obstacle at the bottom of the slant road, you can now say that the upper fruit from the basket move off from the basket, while those ones that inside the basket under remain at rest, and this is due to inertia of motion. Number 5 is swinging pendulum or seesaw. Move tangential to the circle when the spring cut off due to inertia of direction. Inertia of direction as shown from the screen. As the seesaw is moving, if the string is cut off, then the person will move tangential to the circle. Then let's take this one as number 6. A kick, football, moving in a straight line due to inertia of direction. From the diagram shown on the screen, you can now see that when the ball is kicked, it moves on a straight line. That's just to show the inertia of direction. Now, from the 6 examples mentioned now, we can now say that number 1 and 2 show us inertia of rest. 3 and 4 indicated inertia of motion. And 5 and 6 indicated inertia of direction. Now, to mention other examples of inertia now. Other examples of inertia, let's take it as number 7. Throwing pencil up in a moving vehicle. This one is inertia of motion. Inertia of motion. Number 8, turning of a bike. Turning of a bike or bicycle. This one also is inertia of direction. You change direction. Number 9, jumping off from moving bus or train. This one also inertia of motion. So to mention but few, all these one are examples of inertia. This is convenient point to stop for today. In our next class, we are going to inertia mass. So today we've looked at definition, various example and illustration of inertia. So when we meet in the next lesson, we are going to inertia mass. So if you are just joining us, please don't forget to like, share, and subscribe. So when I upload a new video like this, you'll be able to get the notification in time. Thank you.